Hello, good afternoon. Good afternoon, my dear student. Today we will discuss a new topic, that is network graph theory. So far, we have discussed in details about the concept of node, junction, loop, mesh, and also branch. Okay. This terminology are associated with a network or circuit, and network or circuit is nothing but a interconnection of some elements including passive and active. Passive component, for example, resistor, capacitor, and inductor. On the other hand, active components are different energy sources, including voltage source and current source. Okay. Now we will extend the concept of network in terms of other terminology. Let's say tree, twigs, links, then Cartesian incident matrix, etc. We will discuss in detail about these terms. So before going to discuss those important terms, let me tell you what is graph for a network. Suppose you have a electric or electronic circuit. How do you design the graph? How do you represent the graphical representation of this network or circuit? The graph of a network is a useful concept or useful way out that is used to analyze a complex circuit more easily. So let me first tell you what is graph. Okay, what is graph, or how do we define the graph for a particular network, or for a given circuit? Graph for a given circuit. Okay, graph is a representation of a network in which the circuit components are replaced by the lines. The circuit components are replaced by the lines with circular dot at its both end. Okay, so let me write this definition. The definition of network graph. What is a network graph, and how do we define what is a network graph, and how do we define the graph for a particular network? When the circuit elements, all the circuit elements may be passive or active circuit elements. Let's say resistor, capacitor, inductor. In a network are replaced by the lines with circles or dots at both ends. both ends Such type of configuration, the configuration is then called graph of the network. The graph of the of the network. Okay, the graph is nothing but a representation, a simplified representation of a network in which the circuit elements are replaced by the lines, and these lines are associated with circular dot at its both ends. I will explain this concept by taking example of different circuit. Okay, and one thing you remember, this type of graph consists of all nodes of a network. You know what is node? Node is nothing but the point or junction at which two or more circuit elements join together. Okay, join together. The graph of, you just remember this thing, to design a graph for a network you must consider all nodes of the graph, and you replace the circuit elements, especially passive element, by the line, and active element sources, voltage source, you must be replaced by a short circuit, and current source you must replace by an open circuit. So let me write here the graph of a network. The graph of a network is is drawn by keeping all the points of intersection, means nodes, all the points of intersection of two or more elements, two or more elements two or more elements and representing the network's elements of line, more branches, you write it's better, branches. Okay, branches, and representing the network elements of lines, and voltage source voltage or current current source voltage or current source by their internal impedance, by its internal impedance. Okay, the graph of a network. Okay, the graph of a network is a simplified representation in which the passive elements are replaced by lines with dots or circle at both ends, and active elements, voltage source or current source, are replaced by their internal impedances Okay, if you have any doubt to understand the graph of a network, you write in your chat box. Okay, graph, when all the circuit elements in a network are replaced by the lines with circular dots at both ends, the configuration is then called the graph of the network. To draw a graph for a particular network, we must consider the nodes or points of intersection of two or more branches. Okay, and elements, representing elements of lines, voltage and current source by their internal impedance. Okay, This is graphs. Now we will try to understand the terminology, important terminology which are associated with this graph. The first thing is tree. What is tree? We will try to understand because we have already discussed about node, junction, branches, loop, mesh, etc. The new terminology we will discuss here. We will discuss the new terminology which are associated with graph here. And another important thing you must be remember that the graph theory or the concept of graph theory is useful in analyzing the complex circuit. Okay, for simple circuit we can directly use, we can directly calculate its voltage current by using the mesh or loop equation, mesh or node equation. Okay, that means KCL or KVL, that concept. But for complex circuit you can use the graph theory to simplify the solution part. Okay, now let me tell you what is tree. What is tree for a graph? What is tree for a graph? Okay, what is tree for a graph? Tree is nothing but the interconnection of open set of branches, okay, which include all the nodes of the given graph. Okay, so let me write it here. It is an interconnected interconnected open set of branches, which include all the nodes of the given graph. Okay, all the given graph. In a tree of the graph there cannot be any closed loop. That means open set of branches mean what? There is no closed loop. There you just mention it. In a tree of the graph there cannot be any closed loop because we have mentioned that open set of branch. That means there is no closed path. Between elements. Okay, tree, this is an important terminology which is associated with graph theory or graph. We will calculate tree for a particular graph later. You just try to understand what is tree for a graph. It is an interconnected open set of branches which include all the nodes of the given graph. In a tree of the graph there cannot be any closed loop. Okay, and what is twig? The branch of a tree is known as twig. Let me write it here. Next important terminology associated with tree is what is twig, twig. Okay, actually you see there is a hierarchy. First we will consider graph for a given network. Then we will try to understand tree which is associated with graph. After that you see twig is associated with a tree. Okay, the twig is nothing but the branch of a tree. It is any branch of a tree. Okay, that means branch of a tree is known as twig. Okay, branch of a tree is known as twig. Another important thing is link. It is the branch of the graph that does not belong to the particular tree. Let me write here. What is link? What is link? These are important terminology. We will calculate the number of twigs, number of tree, number of links for a given graph in letter. Okay, one letter. What is link? What is a link for a graph? Okay, actually this is not a part. This is not a part of a tree. Okay, it is that branch of the graph that does not belong to the particular tree. Let me write it. It is that branch of a graph that does not belong does not belong branch that does not belong to the particular tree. Okay, that means links is a branch. Links is a branch of a graph, but it is does not associated with a tree. It actually separate branch from the particular tree has a number of branch, but the branch which is not a part of a tree, of a given tree, that branch is known as link or a graph. Okay, let me repeat whatever we have discussed. First, I told you what is graph for a network. Graph is a simplified representation of a circuit in which passive elements of the circuit are replaced by the lines and active elements are replaced by their internal impedances. To draw a graph, we need to consider all the nodes associated with a network and the branches okay, branches must be replaced by the lines or line segment, and sources must be replaced by their internal impedances. After that, we have discussed about tree. What is tree? Tree is an interconnected open set of branches. Why open set? Because there is no closed loop in a tree. There is no closed loop in a tree. That's why open branches. But it must consider all nodes. Okay, we will consider the branches which connect the nodes, all nodes for a given network. Okay, so that means tree may have different from for a particular network. We will see a tree means for a network there may be different tree. Okay, because you see this is an interconnection of open set of branches which include all nodes. Okay, so for a particular circuit there may be different form of tree. Okay, after that we have discussed twig. What is twig? Twig is the branch which consists or comprise of the tree. Finally, we have discussed link. Link is nothing but the branch which is not a part of the tree or which does not belong to a particular tree. Okay. Now, I will tell you another important terminology that is known as card set. That is known as card set. What is card set? What is, you just uh, try to understand the name of this terminology. Cut set. Cut set means you this concept or this link can divide a network into two or more parts. Okay, what is cut set? Actually, it will divide the network into two main parts. Okay, so it is the set of elements or branches of a graph that separate two main parts of a network. So let me write it. It is that set of elements or branch, okay, of a graph that separates separate main parts of a network, main parts of a network. We will see later. It is that set of elements or branches of a graph that separate two main parts of a network. Okay, so therefore for a network there must be at least one cut set or more than one cut set. Okay, we will see later what is cut set. So like cut set, it is that set of element or branches of a graph that separate main parts of a network. Therefore, for a particular network or particular graph, there must be at least one cut set or more than one cut set may represent, but at least one cut set will be present for a network or for a graph. Okay, now let me tell you the relation between links, node, branch. Okay, before that you write the properties of a tree. We will calculate different terminology for a graph. Before that you write the properties of a tree in a graph. Everyone write the properties of a first property is it consists of all the nodes of the graph. It consists of all the nodes of the graph. Okay, second properties is that if the graph has n number of nodes, the tree will have n minus 1 branches. You just write it. If the graph has n number of nodes, the tree will have n minus 1 number of branches. N minus 1 number of branches. You just write within bracket n minus 1 number of will have branches. Okay, third property is that there will be no closed path in a tree. There will be no closed path in a tree. Okay, and the final one is there can be many possible different trees for a given graph depending on the number of nodes and branches. I already told you this thing. There can be many possible different different trace for a given graph, for a given graph depending on the number of nodes and branches. Number of nodes and branches. Okay, you have any doubt regarding the uh, concept of graph, tree, twig, links, and properties of a tree, you can write in your chat box. Okay, you can write in your chat box. We have discussed about the network, what is network, what is passive element, what is active element, how do you design a network by using the passive and active elements. Okay, what is a graph, how do you represent a network by using a graph. Okay, what is branch, what is node, junction, you know already. Now we are discussing about tree, twigs, links, cut set, and properties of a tree in a graph. Actually, you remember that tree, twigs, links, cut set, everything, these terms are associated with a graph. Okay, so let me repeat the properties of a graph of a tree in a graph. Tree must contains all nodes for a given circuit, or given graph. What is node? Node is the point of intersection of two or more junction or branches, okay, or elements. Second properties of a tree is that the number of branch for a tree will be equal to n, capital N minus 1, where capital N is the number of nodes. So therefore, the number of branch or number of twigs, you know, that branch which is associated with the tree is known as twig. So the number of twig is equal to total number of nodes minus 1. Third property is that there will be no closed path for a tree because it consists of open set of branches. Interconnection of open set of branches. And third and final properties is that there may be a number of tree for a particular network or particular graph depending on the number of nodes and branches. Okay, now we will calculate the number of tree, number of twigs, links, branches, etc. for a graph. So before that, we will represent the graph for a particular network. We will draw the graph for a particular network. Let me give you a problem. Okay. Suppose you consider a circuit. A circuit consists of resistance only. Resistance only. Okay. Let me draw it. Suppose this is resistance. Another resistance is connected here. Okay. Now you connect this with wire. This is our wire. You connect with wire. Okay, everyone draw this circuit. Now we will understand the graph for a particular network. Now you give a supply. You just consider a supply here. Okay, this is suppose your voltage source. Okay, okay, this is a circuit. This circuit has this are resistance. Okay, these are resistance. You just write it here. This is our resistance R1. You consider this one, this resistance is R2, R2, and this is our voltage source. You consider this is a voltage source. Okay, voltage source. You just write V, no problem, and plus minus. Okay, you just connect it properly. Okay, everyone look at the present picture. I have drawn a circuit which consists of two resistance R1 R2 and one voltage source capital V. One voltage source having voltage of capital V. Now you draw the graph for this network. This is a pure resistive network. I mentioned that before I mentioned that to draw a graph or a given network, we must replace the passive element by line and active element by their internal impedances. Everyone must remember this thing. To design or to draw a graph for a particular network, first we will replace all passive element of the network by the lines and active element by their internal impedances. So therefore you see that resistance are passive element, we can replace them by lines, and voltage source is a active element, we can replace the voltage source by its internal impedance. And here you consider the voltage source is an ideal voltage source, and you know that for an ideal voltage source the internal impedance is 0. So we can replace the voltage source by short circuit. So now everyone draw the graph equivalent circuit of this network. So we can draw the graph for this network like this. You just, and you know that is line with circular dot at both ends. So how many nodes here? 1, 2, 3. This node is reference node. Okay, you just use here to bubbles and one reference node. Let me draw it here. This is our reference node. You draw it yourself. Okay, node 1, node 2, node 2. Okay, you just node 1, node 2. Okay, this is node 1, node 2. Okay, now this is reference node, node 3. This is R1, this is this R2 element replaced by another line, and the voltage source is replaced by a short circuit. Okay, so you just denote this one as node 1, node 1. Okay, this node as node 2, this node as node 2, node 2, and node 3 you just consider node 3, reference node. Okay, everyone try to understand the graph for a given network. How do you draw the graph for a given network? You see, this is one node. Node is the connection between interconnection, point of interconnection of two or more elements. This is voltage source, resistance. Therefore, this connection is a node. Means a node is present. Node must be present here. And this connection, you see R1, R2, there is also another node, and V and R2, there is also another node. So this is reference node, connection between R2 and voltage source V. This one, node 1 is the interconnection between voltage source and resistance R1, and node 2 is the interconnection between resistance R1 and R2. Okay, so therefore the equivalent graph. This is the network, and this is the graph for this network. This is our network, network, and this one is our graph for this particular network. Graph for this particular network. Okay, everyone, look at the present slide and also present picture. I have considered here a resistive circuit which consists of two resistors R1 and R2 and also a voltage source, active element. To draw the graph for this network, we have replaced the circuit elements R1 and R2 by the line with with dots or circle at both ends of this line, and the voltage source is replaced by its internal impedance. Internal impedance 0. That's why we have considered a short circuit between node 1 and 3, which is nothing but the representation of the interconnection between voltage source and resistance R1 and R2. Okay, if you have any doubt to understand the graph of a network and to draw the graph of a network, you can write in your chat box if you have any doubt. Now you tell me, how, now you tell me how do you draw a graph for a network which consists of these two resistors R1, R2 and a current source. You just replace the voltage source by a current source. Suppose you consider this one is a current source, then what will be the graph for this network? I. Okay, current source. This graph actually corresponding for a voltage source. Now you replace this thing and you remove this graph. Okay, what will be the graph for a current source? Okay, for a current source. Okay, the present graph is corresponding to a circuit consists of voltage source. Now everyone replace the voltage source by a current source. Okay, and you draw the graph for that circuit, and you tell me your answer. Okay, you tell me your answer. Everyone try to understand clearly about graph, links, twigs, tree, cut set and properties of tree, because these are important terminology used to calculate the voltage and current for a graph. Okay, in order to simplify the calculation of a complex network, now you draw the graph for the given circuit. In that circuit I have replaced V by I. This is, that means it is a current source. So what will be the graph for this circuit? So you know that, anyone can tell me, anyone can tell me what will be the change actually, what type of change will occur in the present graph if we consider current source. I have already mentioned that the active sources, voltage source or current source, must be replaced by their internal impedances. And you know that for a current source, internal impedance is infinity, ideal case. That means you just replace this path. Okay, open circuit. This will be the graph for this network. If everyone look at the replaced by internal, which yes, Saiba, your answer is correct. Current source will be open circuited. Yes, Atripal, Atri Saiba. Okay, your answer are correct. Now, what about other student? Other student, write your answer. Okay, you respond it. So therefore, the link between node 1 and 3 must be replaced by an open circuit. Yes, Nivedita, you are correct. One end will be open. That is one end, not one end, one line. One line must be opened. That line actually corresponding to node 1 and 3. In between node 1 and 3. You see, everyone see. Okay. Now you, okay Nivedita, you are right. Now you tell me tree. How many number of tree you can draw from this circuit? Number of tree, number of twigs and number of lines. Okay, number of link. My next question is that you calculate number of trees for the given network, number of links for the given graph, number of twigs for the given tree. The next question for all of you is that calculate the number of trees, number of twigs, number of links for the given graph or for the given circuit. Everyone, solve it. Tree, what is tree? Tree is nothing but an interconnection of open circuit branches, okay, which consist of all nodes in the given network. Okay, there will be no closed path. There will be no closed path. In a tree, the branch of a tree, any branch, is known as twig. For the given graph, you see how many number of twigs? 1, 2. There are total 2 number of branches. Okay, this, and it is open circuit, 2 branch. So therefore, number of twigs is true. Number of tree is 1. How many number of links? 1 links. You see this if you, this part is not, this line is not a part of the tree. Actually, I mean this line does not belong to the given tree. Okay, let me draw it. Everyone try to understand this point. This is an crucial point. Okay, You just let me draw it. Okay. Now you format it. Format it. Okay. You just consider this line style. You consider dash style to distinguish it from the tweaks. Okay. So therefore this part, this line actually, this line is called links. This is link. Okay. The dotted line indicates link and solid lines indicate tweak. I already define it. Tweak. Okay, there are total two tweak. This one and also this one. The another solid line between reference 2 and 3 is is also a tweak because this is a part of a tree. Tweak. Okay. So therefore number of link is 1 and number of twig is 2. This is not a part of this tree. Okay. Everyone try to understand the concept of twig and link. You just remember the definition of twig and link. Let me repeat it. Twig, it is any branch of a tree for a graph. Okay, that means the branch of a tree is known as twig. And what is link? Link is a branch that does not belong to any particular tree. For this network, the tree is this part. Okay, and the dotted line, this is a dotted line. Okay, this dotted, these two are solid line and this one is dotted line. Okay, the dotted line indicates, you just replace the color. You can replace this color, red color. You make it red color, then it is easy for us. Uh, Color, line color, not, you just consider red. Okay, so red dotted color line indicate, red dotted color line indicates link because this line does not belong to the given tree, does not belong to the given tree. Okay, does not belong to the given tree, and twig is a part of a tree. The branches with is associated or with con, comprise the tree. Okay. Now everyone tell me what is the number of tree for this given network. I have considered here one tree, but you can draw a number of tree for a given network by considering the number of nodes and branches. By considering the number of nodes and branches. Okay, number of nodes and branches. Okay, if you have any doubt regarding the concept of graph, tree, twig, link, etc., you can write in your chat box. Okay. Now let me give you another problem. Okay. You solve it yourself. You consider a network like this. Suppose you consider resistance, then you consider capacitance, then you consider another resistance, another inductance. Okay, this is a circuit. Okay, let me first draw it, then you solve it yourself. Everyone, this is a circuit network. This network consists of resistance, capacitance, inductance. Okay, resistance, capacitance, inductance, energy storing element and energy dissipating element. Okay, energy storing element and energy dissipating element. There is one voltage source, you consider it, then you consider connection. Okay, this complete it, this indicate disconnection, you complete it. Complete. Okay, now let me denote it. This is an resistance R1. This part is a capacitor C1. This one is an inductance L1. L1 unit is Henry, Farad and ohms. Okay, R2. And this one is a voltage source. This one is a voltage source, capital V. Okay, now everyone draw its graph. Draw its graphs. Oh look, what happened? Hello. Okay, everyone solve this problem. I have given a circuit or network which consists of resistance R1, R2, capacitance C1 and inductance N1 and also a active voltage source. Now you draw its graph or equivalent graph. Everyone draw it and tell me the answer. What will be the graph? And then you calculate the number of tree, number of twigs, number of links. Okay. So first step is to draw a graph for a particular given network. First step 1 is you replace the passive element by the lines. Okay. And active element by their internal impedance. And you must consider all nodes. What is node? Node is the point of interconnection of two or more circuit elements. Okay, so therefore for this network you see that there are total how many number of nodes? 1, 2, 3, 4, total 4 nodes. This one common node, 1, 2, 3, 4. Okay, total 4 nodes. Everyone look at this one node connection between three elements C1, R1 voltage source. This is another uh, nodes connection between element R1, C1, L1. This is another node connection between L1, R2, and the final one, fourth node, is the connection between R2 and voltage source. So therefore you consider total 4 nodes and replace the active sources by their internal impedance and passive sources by simply a line. So therefore we can draw the graph of this network like this. Okay, and you must consider actually node is represented by a circle. Okay, by a circle. Everyone do it yourself. I have mentioned many times. Okay, two nodes, node 1, node 2. Then you connect with another lines that this represent uh, you consider voltage source replaced by a short circuit. You consider another node here. Everyone must mention the symbol of node with a dot or encircle it. Okay, you draw it yourself. Then you connect L1 replaced by a line. This connection, you another node. Everyone solve it yourself and tell me the answer. Okay, then R2. Okay, you see this one node between R1 and this node and voltage source replaced by this is common node. You just replace this node by a common line. Okay, replace it. You just consider this connection. You can replace this one by a single combination of these two by a single branch. Okay, L1 and R2, L1 and R2. Okay, this 1 2 voltage source here connected by shorted. Okay, and these two branches, you can these two element can be replaced by a single branches. Okay, this is an important point. You can replace combination of element by a branch. Okay, you can replace combination of element by a single line. Okay, combination of element by a single line or branch. Okay, so that's why we have taken here only 3 nodes and 3 branches, because we can replace a combination of branches or element by a single line. So R1 C1, these two elements are replaced by a single line, and the combination of element L1 and R2 is replaced by a single line. Okay, and voltage source is replaced by a short path. Okay, if you have any doubt to understand this point, you can write. So here you just write one important note, note down it, note it, that a combination of elements or branches can be replaced by a single line. Okay, replaced by a single line. Single line. Okay, everyone note down this part. Okay. If you have any confusion or doubt to understand the graph for the given network, you just inform me. What is your confusion or doubt? Okay, here you see that C1 and R1, these two elements, the combination of these two elements is replaced by a single line, and the combination of L1 and R2 is replaced by a single line. We can do it. Okay, we can consider two lines, two branches. Okay, no problem. Otherwise, we can replace two branches by a single branch. Okay, we can modify it or more simplified representation. Okay, you can consider another branch here for C1 and another branch for R2. You can consider another nodes in between these two nodes, no problem. But for simplified representation or more compact form representation will be look like this. You can replace combination of two elements or branches by a single line. We have utilized this uh, concept here. Okay, any doubt, any problem? Okay, so what will be the number of nodes? Total nodes is 3 for this case. What is the number of tweaks? Total number of tweaks is 3. No, not 3, because this considered a closed path. Then how do you design? You can consider this. You can consider first you draw the tree. You can consider these three. Let me clarify it. This is a graph. Okay, now let me draw. We can draw a tree like this. We can draw. Everyone look at the present picture. If we replace one line between two nodes, we can say it is a tree. Tree must contains all nodes, but there is no close path in a tree. So if I remove the link between these two nodes, end nodes, I can get a tree. I can get a tree. Twig is 2, right, Nivedita? Twig is 2. But Nivedita, can you tell me number of links and tree? Other student also try. Other student try to solve this problem. I have already solved first type of problem. Number of twig is 2. Okay. But how many number of tree you will get? And what is the number of link? You see, if you replace 1, this is a tree. Contain all nodes. Link is 1. Thank you, Nivedita. Link is 1. Correct answer. Okay. Other student try it. Okay. Now let me draw another tree. Suppose I can replace this one another tree. I can consider another tree by depending on the number of nodes and links. You say next tree, there may be a number of tree for a given graph. For a given graph. Okay. It must contains all nodes, and there actually it does not contain any closed loop. You just remember this thing, then you can draw number of trees. Okay, let me show you another tree. You can draw. You can if you replace the link between other 2 points, then you will get a new tree. Okay, you see, now you see. Okay, this is another tree. Similarly, you can remove the topmost link, you will get another tree. Total number to 3. Okay, so there is a formula to calculate tree, we will discuss later. Just this is one kind of uh, hypothetical approach means repeated. We can replace one link, we check this is tree, like this we can calculate the number of total tree, but there is a formula to calculate the number of tree for a given network. We will see that part in next class, and we will discuss another important topic, that is incident matrix for a given network. One thing, let me tell you, this is the final topic for our syllabus. Okay, this is the final topic for our syllabus. After completing this, if we have some time, then we will solve problems related to all topics whatever we have covered so far. Okay, let me first complete this topic. I hope in next class I will complete this topic. Okay, so this is our final topic, this is the final topic for our syllabus. Okay, thank you everyone. If you have any doubt, any difficulty for understanding this uh, topic, you can write it in your chat box. Thank you everyone. Let me stop today lecture here. Okay.